Last year, a single configuration change in a caching layer took down a major e-commerce platform for 3 hours. Revenue stopped, dashboards flatlined, and the root cause wasn't a hardware failure or a malicious attack. It was a developer who deployed a cache setting that seemed perfectly safe at the time. I'm Reza Mahdavi, engineering lead at Xentro, and I've watched this exact mistake happen more times than I'd like to admit. But here's what's actually happening. Caching is not a simple on-off switch. It's a memory system that sits between your users and your database, holding pre-computed answers so you don't have to recompute them every time. When it works, pages load in milliseconds, APIs respond instantly, and your infrastructure costs drop. When it doesn't, you get stale data, broken checkouts, or a stampede of requests that knocks your entire backend offline. The mechanism is deceptively straightforward. You take a piece of data that's expensive to generate, a product listing, a user profile, a search result, and you store it in a fast access layer like Redis or Memcached. You assign a time to live or TTL, which tells the cache how long to hold onto that data before it's considered stale. The next time someone asks for that data, you check the cache first. If it's there, you serve it. If it's not, you compute it from the database, store it in the cache, and serve it. That's a cache hit versus a cache miss. But the real complexity lives in the gaps you don't see. Cache invalidation, knowing when to toss out old data and replace it with fresh ones, is one of the hardest problems in computer science, and it's where most outages begin. A classic trap is the cache stampede. Imagine a popular item's cache entry expires at the exact same moment 1,000 users request it. Those 1,000 requests all hit your database simultaneously because the cache is empty. Your database, which was comfortably handling a few hundred queries a second, suddenly faces a wall of traffic. If your connection pool or your query optimizer isn't prepared, the database slows down, then times out. Then your entire app becomes unresponsive. Amazon found that every 100 milliseconds of additional latency cost them 1% in sales. A stampede can add seconds, not milliseconds. You can do the math. Another trap is what I call the phantom cache, a cache that returns stale data without anyone noticing. You update a customer's shipping address in the database, but the cache still holds the old one. The checkout process reads from the cache, shows the old address, and the package goes to the wrong house. No one gets an error message. Everything looks fine until the complaint arrives. Google once published a study showing that a mere half-second increase in search page load time reduced traffic by 20%. Now imagine the trust damage when a wrong address costs a customer a delivery. That quiet failure is far more dangerous than a loud crash because it erodes loyalty without any alerts to tell you it's happening. Here's the counterintuitive twist. Sometimes not caching is faster. When your data changes constantly, like a live auction bid or a real-time stock price, adding a cache layer introduces a delay in propagation, and the overhead of checking and invalidating can actually slow things down. The fastest route to the user is often a direct, well-indexed database query. I've seen teams cache everything by default, only to find that removing the cache on a frequently updated endpoint cut response times in half. At Xentro, we moved a client's API response time from 2 seconds to under 200 milliseconds by removing a poorly designed cache layer and optimizing the database queries instead. Their checkout abandonment dropped by 50% in the first week. So the next time you're tempted to just add a cache to fix a performance problem, pause. Ask yourself 3 questions. 1. What's the worst case scenario if this cache serves stale data? 2. Do I have a plan for cache invalidation that covers every write path in my application? 3. What's my defense against a stampede? If you can't answer those clearly, you're not adding a safety net. You're adding a silent failure point. This week, take one critical endpoint in your stack, look at its caching layer, and test what happens when the cache is completely empty. Because the most dangerous line of code isn't the one that crashes your app. It's the one that quietly corrupts your data while all your dashboards stay green.